Hello and welcome to the video on the keyboard instrument project. First of all, let's go through the circuit. So we got our piezo buzzer connected on pin 8 to the positive side, and the other side is connected to ground. We've powered our positive and negative rails on this side. If any of these buttons is pressed, it'll deliver a certain voltage to A0 based on what resistor is hooked up. It's a little hard to tell how the circuit is set up in this diagram, but it is more obvious if you look at the schematic diagram. So we connect 5 volts to A0 through a variety of resistors depending on which button we pressed, and we have a 10 kilo ohm pull down resistor. Now feel free to vary these resistors. 10 kilo ohm is not a bad pull down resistor. Maybe 5 kilo ohms is a good one depending on what values you're using. You can add more buttons. It's pretty easy to do just by different resistors. Also, you can set it up more similar to a traditional resistor ladder, and if all of these resistors are the same, it will give you a better spread of voltages if you have a lot of buttons. Though this works great with just our 4 buttons, but if you want to go more, you might want to switch your type of resistor ladder. This is also nice in that it doesn't have a ton of parts. I'm not a huge fan of which resistors were picked for this. I'd probably go for like a 5 kilo ohm personally, and then like straight wire, 220, 5 kilo ohm, 10 kilo ohm, and maybe like maybe 100 kilo ohm. Something like that. Anyway, if you want to figure out what voltage will go to A0 based on your choice of pull down resistor and resistor connected to the button, what value you'll get from analog read, I've made a formula for you so you can check that out. So your analog read value should be roughly 1023, the max possible read value, times the whatever resistance you got for your pull down resistor, divided by the resistance of the pull down resistor plus the resistance of the one in series with the button. So if you think about that one for a while and try it on those, check to see if it works, because we'll be reading our analog values and printing them to the serial monitor, so you can check that it's roughly accurate. Keep in mind, wires can have some resistance as well, and connections, so it may not be 100%, but it should be pretty darn close. Anyway, so back to the circuit. So we can totally play with this if you want, but you don't have to. Let's go talk about the code. Now, first thing I want to bring up is I think it was a bit of an error in the book to include this section right here. One, because it looks like it's part of the circuit, and it totally isn't. So if you include this code, it won't even compile because it's not accurate. There's actually no problem with this line. It'll just create an array called buttons that holds 6 buttons. This isn't set up right though. I don't know what's trying to go here. I think maybe they just shouldn't have included the int there. If they've already initialized buttons, just having button 0 equals 2 would be fine without the int. But regardless, you can ignore this. This isn't actually part of the keyboard instrument code. That starts at line 1 right here. And right here we've got an array where we're holding our various frequencies that we're going to play depending on which button we press. So this is middle C, and then a D note, and then an E note and F note. So we got 4 notes to play with. You can add more buttons, or you can switch which frequencies you're playing and look up different notes if you need different notes. But that's it for arrays, or at least initializing arrays. Let's go to void setup. And there we just start talking to the computer at 9600 baud rate, or 9600 bits per second, 9600 ones or zeros per second. And we're doing that so we can report back what value we're getting when we're pressing the buttons and so on. The action's really occurring in loop. So every pass-through loop, we create a new int called keyval and make it equal to the read off the A0 pin. I would personally initialize keyval here just for slight performance improvement, but it wouldn't even be noticeable. So it's really not important. It just feels like bad practice. Anyway, so we read off A0 and then we print out the number we read off it. That'll really help you debug your program. This one right here, I would say probably won't quite work. This is saying, hey, if you press the button that's directly connected to 5 volts, no resistor in it, theoretically, it'll be exactly 1023. It may not end up being actually the case. So double check it. If it makes no sound, then it's totally not working. It'll probably make some sound, but it might be patchy. If it sounds patchy or terrible, look at the values you're getting. It might be 1023 sometimes, but it might dip down to like 1022 or 1020. So you might want to switch this for key value is greater than 1015 or something like that. And that should fix any patchy sound problems for you. And then if it does fall into the range that you should get when you press the button that's connected directly to 5 volts without a resistor, on pin 8, it'll play the first frequency, our middle C. Remember, our first entry has index 0. And then just more of the same. We're just trying to come up with else-if statements where the condition surrounds a range of values that you get by pressing one of the other buttons. And the voltage that goes to A0 depends on the resistor in series with that button. So this next one will play a D. This is one of the small resistors, probably the 221 is the one this is trying to hit. And then we got our 10 kilo ohm resistor, which makes sense if you look at the formula. If the button resistor is 10 kilo ohms and the pull down resistor is 10 kilo ohms, we should get 2.5 volts at A0. And so we should get roughly half the max possible analog read value. So max is 1023 or roughly 1024. So half that is about 512. So notice that's pretty smack in the middle of this range. So hopefully it'll work. And then if it falls in that range, it plays our E note on pin 8. And then if we get a really tiny value, I really don't think the choice of a 1 mega ohm resistor was a very good one. But there it is. If it falls between the 5 and 10 range on analog read, it plays our last note, our F note. And then if no notes are being played, it turns it off, which is pretty nice. We could also do like just an else if, maybe it's less than 1 or less than 2. With the pull down resistor, if none of the buttons are being pressed, it should make, or it should be at 0 volts or pretty darn close to it. So you might want to change this to an else if, or not. It works great as is. And that just, because the way we're using tone here, it'll keep playing it forever. So it's important to have a no tone in there. Otherwise you press a button and you just hear that tone forever. If any of you forget this little else statement, you'll find you'll press a button and it will never not make sound again until you turn it off or hit the reset button. So that's pretty much it. Yeah, we're just trying to make a little keyboard here to play. And that's it. Thanks for listening.